Hello and welcome back. This is Saxon Math Course 1. We're looking at rounding whole numbers and estimating. I'm going to move fairly quickly through this because you have 15 practice problems. They aren't very long practice problems, but there are 15 of them, so let's move through this. It is a new concept, but let's look at it carefully. When we round a whole number, we are finding another whole number, usually ending in 0, that is close to the number we are rounding. The number line can help us visualize rounding. So here we have a number line for 600 to 700, and it is in increments of 10. Here you have 667 on the number line. In order to round 667 to the nearest 10, we recognize that 667 is closer to 660 than it is to 670 than it is to 660. See, if you look at it, it's 7 away from 660, and it's only 3 away from 670. So 667 rounded to the nearest 10 would be 670. If we were rounding to the nearest 100, we would recognize that 667 is closer to 700 than it is 600. It is 67 away from 600, while it is only 33 away from 700. So it's closer to 700 if we are rounding to the nearest 100. To round whole numbers, you can underline the place value you're rounding to. So if we had like 385 and we wanted to round it to the nearest tens, we'd underline that number, tens place. Circle the digit to its right, which would be the 5 is to its right, and then ask yourself these questions. Is the circled number 5 or more? If so, you would add 1 to the underlined number. This is a 5, so because it's a 5, we rewrite this as this, and you add a 0 in place of that. If it's not 5 or more, then that number stays the same. The underlined number would stay the same. So that would be like this, for example, if it was 384 and we're rounding to the nearest 10, you would notice that 4 is actually less than 5. That would mean that this 384 would be closer to 380 than it would be to 390 if we're rounding it to the nearest tens place. Then you replace the circled number and any numbers after it with 0, just like I did here. So I just created the 0. So an example, 472, if you want to round it to the nearest 100, you can see it on a number line. You've got 400 or 500. Which one is it closer to? If you put 472 accurately on a number line, you would see it would be beyond the 450 mark, and anything 450 and over would be closer to 500. So, and here it is, if you were to underline the value you were trying to round to, the hundreds place, and you circle the digit after it, the 7, you would recognize the 7 is 5 or more, which means you would change this to a 5. You would add 1 to the 4, turning it into a 5, and then dropping all the other digits and turning them into zeros. So technically, if you're looking at the number line, it's either you've either got this option, 500, or you have the 400 option. There are no other options. You're not going to say 600 or 300 or 900. Those are the only options you have. Also, estimating. To estimate answers, you round the numbers before we add, subtract, multiply, and divide. So if it said something like 385 plus 20, we would round those to, well, let me do it to make it even more challenging. Let's say it's 21. I would round those to, and this isn't the exact answer, but I would probably round this one to 390 and then round the other one to 20, and I can do that mentally. I know that this is going to be 410 because I know what 39 plus 2 is 41, and then be 410. So that's an estimation. We don't want to do the estimating after adding those values. You want to estimate prior to doing any addition, subtraction, multiplication, or division. Let's round 109 to the nearest hundred. Well, if you have 109 on the number line, that would be approximately right here. And it says to the nearest hundred. On this number line, we actually don't have, let's say we've got 100 right here. So it's either going to be 100, or you can see 200 would be way over on the other side. Over here, you probably can clearly see that it's going to be 100 is the best answer, because 100, if we're underlining the ones digit and then we circle the digit after it, you can see that 1 stays the same, and then the rest of these digits turn into zeros. So 100 is the nearest hundred for 109. And you know that it's only 9 away from 100, and it's 91 away from 200. So you can see very clearly that it's closer to the 100. How about rounding 109 to the nearest 10? Well, 109 is right here again. So if this is 109, the nearest 10 is either 110 or 100. I know 100 is 1010, so it's still considered a 10 value. It's the nearest 10 is 100 or it's 110. And if you look at it, if we're rounding it to the nearest tens, we underline the tens place, we circle the digit after it, and we see that it's 5 or greater. It's a 9, so that means we have to add 1 to that. So we add 1 to that digit and then make the 9 into a 0. The nearest 10 would be 110. Estimating, that basically means getting close. When would you estimate? Well, a lot of the times you're going to estimate when you go to the grocery store, or if you just need to have an approximation of a value. You don't need the exact amount. An exact amount isn't incredibly important. An estimation is getting close so that you know, do I have enough money in my pocket when I get to the cash register after putting some items in my basket? That might be a good time to estimate. But estimating, if you're going to estimate things, you figure out what your operation is going to be. Is it addition, subtraction, multiplication, or division? In this case, it's a sum, so we're going to add. And it says 467 and 312. Well, in this case, I would probably, if I was going to round these to the nearest hundreds place, I'd have to do both of those to the nearest hundred. So it'd be 500 plus 300, and I would see that that would end up being 800 for the estimate. And you see, I do not do 467. I've seen kids do this. 312. I've seen them go through all the painstaking process of adding these up, and then in the end they rounded this and they said, I got 800, I did it right. No, do not do this. This is wrong. When you're estimating, you have to round those things first, and then you can do the operation. You still will get the correct answer, obviously, and sometimes you won't, but do the estimation first, the rounding first, to get your estimate. Here it says estimate according to this graph, about how many more people lived in Ashton in 2000 than in 1980. So in the year 2000, I can see that value is at 7,000 people in the year 2000, and in 1980 it has 4,000 people. So in this case, it's simply 7,000 minus 4,000, which would be an estimation of 3,000 people more lived in Ashton in 2000 than in 1980. All right, round each of these numbers to the nearest 10. Letter A, go ahead and do that. All right, to the nearest 10, you should have gotten 60. It was either going to be closer to 50 or 60. And if you're underlining the tens place, that's the 5, and you see 7 is greater than 5, so that means this needs to have a 1 added to it, and then drop the 7, turn it into a 0. 60 would be the answer. Letter B, 63. 63 rounded to the nearest 10 would be 60. Because if you look at it, the tens place, 3 is less than 5. That remains the same. 6 remains the same. The 3 turns into a 0. How about letter C? 45 should have been changed to a 50. The nearest 10, I understand they're both 5 away from it, but anytime you've got 5 as the digit following this place value you want to round to, we're rounding to the nearest 10, we need to add 1 to the tens place in this case. The answer would be 50. All right, do letter D. 282, but it says round it to the nearest 100. So we're rounding to the nearest 100. 282 rounded to the nearest 100 is 300. Your options are either 300 or 200, and you can see that if you underline the hundreds place, that's this 2, and then circled the value behind it is an 8. 8 is greater than 5, which makes this become a 3, and then all those digits after it should turn into zeros. How about letter E, 350 to the nearest 100? This one should have been 400. 400 would be your answer because this is a 5 or greater. So this digit right here that would be circled, and this digit is underlined. You have to add 1 to the 3 to make it a 4, and then drop those other 2 digits and turn them into zeros. What about F? 426 to the nearest 100. Your answer should have been 400 for that one, because if you underline the hundreds place and circle the digit after it, it's a 2, it's less than 5, so that means the 4 remains the same, and this 2 and the 6 turn into zeros. Round these to the nearest 1,000, so each one of these answers should be rounded to the nearest thousands place. You have 4,387. This should be rounded to 4,000, would be the nearest thousands place. Because if you look at it, you underline the thousands place, which is the 4, circle the digit after that, it's a 3. 3 is less than 5, which means the 4 remains the same. And then all the other digits behind it turn into zeros. 7,500 to the nearest 1,000. Should be 8,000 because of the 5 there. Because it has a 5, you need to add 1 to the thousands place that we're rounding it to. The 5 is 5 or greater, means you have to add 1 to it, and then all other digits turn to zeros. Letter I, 6,750. Should be 7,000 in this case. How about letter J? Use rounded numbers to estimate each answer. So remember, you're going to round before you actually do the operation. So letter J. If I was you, I would have rounded this to 400 plus 200 equals 600. Okay, do letter K. 703 minus 598. I would round this one to 700 minus 600, and I would get 100. All right, let's do letter L, 29 times 31. This one I would do 30 times 30 if I was going to estimate that, and I would see that there's 2 zeros hanging off the end there, and then I just have 3 times 3, which makes 9. The answer would be 900. And letter M. 591 divided by 29. I would change that 591 into 600, and I would change the 29 into 30. So I'd have 600 divided by 30, and when I do this, I can see that 0 cancels that 0. Those are canceled out. Now I have 60 divided by 30, and I know that is 20. 20 would be my estimate. About how many fewer people lived in Ashton in 1980 than in 1990? So if I'm looking at 1990, that's this value right here, which is halfway between 4 and 6. So 4 and 6 would be 5. So that's 5,000. So I'd have to take 5,000, subtract it from the people living there in 1980, which is 4,000. So my final answer would be 1,000 people. And more clearly, maybe fewer people. And letter O, the graph shows an upward trend in the population of Ashton. If the population grows the same amount from 2000 to 2010 as it did from 1990 to 2000, what would be the reasonable projection for the population in 2010? So from 1990, it was 5,000, and then in 2000, so in 1990 there was 5,000 people, and in 2000 there was 7,000. So it went up 10. In those 10 years, it went up 2,000. So that was 2,000 people in those 10 years between 1990 and 2000. So if it went another 2,000 to another in the next 10 years, our reasonable projection for the population in 2010 would be, in this case, going from 7,000, 2 more thousand would be 9,000 people. All right, excellent work today, and don't forget to do written practice 1 through 30 for lesson 16 during math class, your 50-minute work period during the day. Have a good night, and we'll see you tomorrow.